All right. So now we are recording. So now we have to behave because we're recording. So you wanted to see again what I just did here, right? So you all remember how to create this extra plane, right? That was just do a plane around this edge. The next thing that I did was because I want to cut away this part, right? So I get my slanted part there. So to do that, I need to do a sketch, right? So I can extrude that sketch. And now I have many different ways I can do that, right? I could just do a rectangle, but I have to be careful that I'm on this edge with my rectangle. I'm not over or under. If I'm over that, then it's going to complain. If I'm not far enough, then it's going to then it's not going to cut everything, right? So if I do a rectangle, right? If that's my rectangle, then of course it's not going to cut enough, right? If I go in and move this one, so it had to, well, let's show you how that would work, I guess. So if I have all this in. So if I were to move my rectangle, but I move it too far, right, like this, then it should complain. Let's see. So I want to cut down to that plane like that. Yeah, I can't do it because it's basically part of my rectangle will never hit that plane going downward, right? So that's why the way that I did it is, let's get rid of that sketch, is new sketch. And then remember that we have this, where do we have the project geometry tool, right? That takes anything that you can see and projects it up to your plane, right? Right now, I can't use any of this because I can't see those lines. They're not on my sketch, right? They're on a different sketch. But if I do the project geometry, then I can get those up. And you can see that they're now on my screen because they turn slightly yellow. Right? To me, that's the fastest way of getting there. I know I'm exactly on the right place. I'm not going to be cutting anywhere where I don't want to cut because I have the exact same shape. Right? So you can see now that I have my sketch up here, whereas my original one was down there. And then I can do the cut. Cut to that right there. And that worked. Does that make sense this time? Okay. All right, so now now we have our flat surface. And we are told that our hole is 17 from this edge and 52 from that edge. And again, some of you just did, 52 times square root of 2 divided by 2, right? That's obviously is correct, but not what we're looking for. So how do we do it here? Well, here we just have to do a sketch onto this plane. It's pretty straightforward. Our sketch here. How big was the hole gonna be? Well, it doesn't really matter how big the hole is, but let's make one in there anyway. 24. So this is obviously not the hole that we're actually going to use, but we can draw that circle. And now we can dimension that in, right? We said that one was supposed to be 52. And then from that corner, there was supposed to be 17. Now I have the right location of, at the very least, the center point of this hole, right? The problem, of course, now is that my sketch is on the surface, right? On this surface, if I do my hole or if I do my extrusion, then of course I get an extrusion that goes inward, right? Goes at an angle, but we wanted to have it go straight down. Now, there's multiple different ways we can do this. For me, the fastest and the easiest is basically do the same that we just did before. We'll do another sketch and we'll do another projection. So what we can do is we can look, either we can create ourselves a new, sketch up, a new plane up there, or we already have a nice flat plane. We can use this one down here. Do a new sketch. And now we want to basically take that center of the circle that we just created and project that downward. All right, so we can say, again, project geometry, where is our circle. Now we can't see the circle. That's annoying. So what we can flip this over and say we want to have that circle. And now if we flip back, we have our yellow circle down here. I did again. Let's go back. Yeah. So I want to have my sketch down here. Now, every now and then I can see it, but not always. So like if you can't see it down here, but I want to project it down, I can look where I can see the sketch, do my project geometry, and then I should have it if I hit it correctly. Then now I can see it. Right. And of course, you'll see that now this is no longer a circle. It's now an oval because we had projected something that was on a slant straight downward. So we have to draw ourselves our circle again. Just have to do the same cross, the same center position. That. Finish. Oh, actually, let's stay down here for our extrusion. Do the circle, not the oval. And we'll cut all the way through. All the way through. That's what we want to do. So the circle is not exactly. No. Right, that's why that 52 is there. And now, if you for those who did the measuring approach, right, we could go back in, look at this sketch, and we can see that it actually comes out to the 32 or something like it. 36. But then you don't know where it is. Right? The problem with your approach, and that is kind of the approach that I was alluding to beforehand, is that some of you just basically left the top surface flat and calculated that if I'm at a 45-degree angle, 52 is 36.6, right? If you just do the math calculation and then drilled a hole straight down. But again, I'm saying that's not a really good approach, because if you change anything else, that 36.6 is not going to change. It's going to stay exactly what it is, right? So if I later on say, like, you know what, I want to have this, like, my very first sketch, right? That was actually not a 60. That was supposed to be, I don't know, whatever other value. Maybe an 80. Right, then everything here should change. Was not able to do it, so that's okay too. Well, because our cut was different now, right? But the idea is that if you measure something in, if you give it exact or give it a number, then it doesn't grow with whatever you do afterwards. So it's better to do that. Yes, I think there are a couple of you that did that. And I think the reason is because the center line kind of goes through one of the corners, and it looks as if it going through there, but it doesn't actually, right? If you draw the center line, it doesn't actually go through that little corner there. Right. Yeah, totally fine. It's just an extra plane that an extra step that is not necessary. But you can always have extra steps. There's nothing wrong with creating them somewhere else. Yeah, that happens. Now, before we go and do the new stuff, I had a discussion after or during class with Monza last time about especially this one, which is a horrible, as you all noticed, right? Is really not good to draw from, because it's not very clear. And so I had emailed you kind of a different version of it sometime after the class, maybe the same day.
Yeah, sometimes the instructions.
Right, but so I emailed you this other version, and is that a better version to use? Nobody saw the email? No, but nobody saw my email? You saw it, but you ignored it.
No secrets when. Yeah, it's
So-
not blood, it's not.
So I basically sent this one around. And so is this gonna be, I mean, for you guys, obviously too late because we're done doing 3D objects, but would this be better in the future to use? Uh-huh. It is. The slot that, and that's why I don't, like, in the end, I don't like those very much, because the slot is what this area down here is the slot.
But it's.
And it's 12 from the center line, where the center line is right here, and so it's 8 from there.
I did it the other way around, I did 8 from the center and 12 from the. That's what I understood, it's not like the.
Yeah. But you have no excuse because you actually did have this this description. All right. Okay, other questions about any of this? Like I've looked at some of you guys, just like whoever handed stuff in yesterday, early evening, I kind of looked in detail, but for the others, I'll have to look sometime today for the homework. But again, that kind of the where to put the hole was the biggest, seemed to have been the biggest issue. All right, now what we want to do, and actually this is a nice segue in a way, is like we now want to do exactly what's on this page here, right? So we've now learned how to do all these 3D drawings, and now we want to learn how to actually get engineering drawings from them, right? Like these nice little PDFs that we can print out are not really all that helpful because they don't have any measurements on them, and they're, you know, they're pictorials. They're not actual drawings. So what we want to do is we want to do kind of these drawings. And the way that we do that is, let me just, we'll draw ourselves another part. Go grab that part. Lecture number. So we are, if you guys are cold, yeah, we can turn off the air conditioning. I'm the only one who's warm. All right, we're gonna try and draw this one, but we're gonna modify it slightly to make it more interesting for what we want to do. So let's get ourselves a new part. Create, let's make this, no, it's otherwise too small. Let's leave these side by side and go back and forth. I think that's on the small screen, that's to do. All right, so we want to draw this. The only difference we're going to do is we're going to have, instead of having kind of this cut in here, we'll have a sloped surface there because I need to show you something with sloped surfaces. But otherwise, we'll do the same thing. Now, there's many different ways we can start. It seemed, again, a lot of you guys will want to draw the bottom and then extrude it all the way up and then cut the two pieces out. What I like to do is if possible, I like to reduce the number of extrusions that I do, just because it's easier to follow along. So what I like to do with these kind of things is I like to kind of go where I see the most detail and draw that surface and then extrude, right? So in this case, I'm just going to basically draw this outline, extrude it back, and then put the holes in. But again, there's nothing wrong with the other approach. This is just the way I like to do it. So I'll start with that corner there. It goes up 30. And then it goes, this is 100 minus 40 is 60 minus 30 is 30. So this is 30, 30. And then we'll go from there. Let's go back to the sketch. Line. 30. And 30. And then what else do we need? So we're now here. No, here, I'm sorry. And then how high is this? This is 30 overall is 50, so 20, and then 40 over. 20 and 40. 20 and 40. And now on the sketch again, it kind of goes steps down and do this kind of L shape. But in this case, I want to do a straight line down. So what I'm going to do is I'm going to do this part and this part, and then I just connect those two. So let's do that. Let's finish our line there. The entire width was 100. And then we have to go up 15, it says. Nope, didn't want that line to create. There we go. And then we can connect it there. And that's my shape then, right? Again, it's slightly different than what we have in the picture. Right here, it kind of does the step down. We'll just do a flat surface here. Sloped surface, because that kind of adds a difficulty in our drawing that I want to show you.
That would be, have the dimensions of like that line.
Right, it's basically just drawing a triangle here and filling it in. Right, so we have. That's what we have, but now I'm just thinking.
You're just doing.
Yeah, just changing. That slope surface once we do. That's all. And it's supposed to be 50 deep. It's easy to do. Extrude 50. Now, next, what should we do next? The holes, right? We can start with this one here. 25 and 13, and they're 20. Sketch. Should grab the center part right there. Let's just put it somewhere. We said it was supposed to be 20. And that distance was supposed to be 13. Well, if we want to, we can check, make sure that the other one worked as well. This should be 25. And it is 25. All right, we can do that extrusion right there. Cut all the way through. That's our first one. Then the one on top says, this is for that there. I don't think it says where it's supposed to be quite honest. I think it's just centered on the block. But I think that's for the cut that's in here, because it doesn't say how far this part is and how far that part is. So I think it just says that this cut here is 20 wide, and like, you know, distance on both is the same. But we'll just center the hole regardless. And it's supposed to be a 30. And how wide is that block? That block is 40, so 20. 20. There we go. And we can do that cut as well. And then we have to add this little box right here, right? So we can just create whatever rectangle we want as long as it's centered here and is 20 wide. Let's do that. Here, this one. This is a normal. Right, it has this cut in here. Well, it's because it, like the circle goes across here, right? Right, it's just that cut makes it look a little strange. But let's get that cut and maybe we can see if it looks how we expect it to look. So we'll have to draw ourselves something down here. Bring that up. Let's do a rectangle, but let's do the one. Yeah.
Like you're doing on the top, but on the side, also.
Oh, for this cut. Yeah, yeah, of course. It's just that, no, it doesn't matter. Right. I think it might be a little easier to do it on the top because you can try to make sure that you're not cutting into thing. If you're doing the extrusion in that direction, you have to make sure how far you want to extrude it, right? There's no measurement telling you how far to extrude it. So it just might be a little trial and error, but it's gonna work the same. Yeah, it says how deep it is. So we know that in this case, in that direction is supposed to be 20. In the other direction, it doesn't really matter as long as it's cut, like, you know, everywhere where we want to. And then let's see what it says. It says right here, it says 15 at that distance. So we can extrude 1.5 downward and okay. And now you can see that hole does look a little strange. Right, that's what we have. All right, and then the last thing, so in our drawing here, we have, of course, that hole in the bottom, but we'll do one on the side. We'll draw a hole here and we'll do it at 20. Do it 20, and we want to dimension it 25 from up here.
You're doing the hole for the side.
On the side surface, yeah. Right, so if I'm, okay, if we want to repeat this, right, so this is now that surface right there. Right, so if I want to sketch here, new sketch, circle, try and hit the middle point here so I don't have to dimension that in, and then I'll just said we wanted to have a 20. That was not good because it connected itself to that other triangle, to the other circle, which we didn't want to. Make sure that's not the right spot. Let's put it somewhere here. So otherwise, if it's connected to that circle, then everything we change makes a difference. And then we'll say that we want to have the center of the circle measured on that plane to be 25 from the top. Yeah, that's, no, I don't want a vertical. I want to have it, I actually want to have it cut through in that direction. Right, I just want to have this here. Right, this is the shape that we want to have. And now we're gonna save that somewhere. Probably already have this somewhere. Let's just do an example part. Oop, have example part. It's fine. Overwrite that one. And let's say save. Yes, because we have another one. And now we want to create those orthographic views. And again, yeah.
But are you missing like the curvature of the hole that connects to the circle? Does that have a curvature?
This here?
No,
No, it's down here. It looks as if it were,
yeah, it looks as if.
Yeah. but it's just, that's just, you know, you can see that in our drawing here too, right? Looks the same way here. In what direction? flip it. All right, it's just a straight cutout. All right, so now if we want to get those views, the great thing is that Inventor does most of the work for us, right? We don't have to go in and draw everything and make everything detailed. It knows all the things, but to do that, we have to give it now something else, right? We talked about parts this entire time. We now want to give it a drawing. Stretch that out a little bit, right? And there's a whole bunch of different drawings that you can choose from. There's 2 different formats and then a whole bunch of different templates. We want to use the IDW, right? So it's Inventor drawing. That's the one we want to use. We don't want to use the DWG, which is an older file format. And because we're doing it in millimeters, we want to do ANSI millimeters. So we'll choose that one. We'll sort of say create, and it will come up with a perfectly nice sheet for us with everything on it that, if you remember all the way back to either the second or the first or the second class that we had, right? We talked about all these different elements that we can see, right? We talked about different sizes of sheets and so on and so on, right? You can see kind of the rim on the outside, a little hard to read, but there's numbers on them. And then there's the main block here. And then of course, whatever we do in here is going to be where we put our drawings. Now, the reason why these numbers all look very tiny is because this is a massively big piece of paper. Right? It looks like it's letter size on my computer, but it's not. Right? If we zoom in, right, we can see that it's actually size D, right, which is a huge, huge, huge plan. We don't want to have something that's size D, right? We want to have something that is the size of our piece of paper, right? So we can go in here, we can say edit sheet, and we can say the sheet size is supposed to be, where's our standard letter size? A is our standard letter size, right? You can also do custom, that's fine. The problem now is, what's the problem now? Now my letters and numbers are all nice and big, it's perfect. But what happened? This box is like way too big, right? It takes off a third of our page, which is useless, right? So what we'll do, we'll actually cheat. We will pretend that our very, very, very big D sheet is our regular size sheet. And if you do it as a PDF, it automatically scales it to the same size, so it doesn't matter. So we'll go back, turn this back to a D. Oops. Right click, edit sheet, and switch it back to D. Now, the problem is that we can't see anything on this, right? But what we can do is we can go in and fix that. We can go to move this to the side here a little bit. We go up here to the Manage tab. And on the Manage tab, we'll see there is the Style Editor. And we click that. And that is something very difficult for Inventor to do, so it always takes like 5 seconds to actually bring it up. Why, I don't know. But it basically allows you to edit everything on, right? Change the parameters for everything on here. And so the first thing that we want to change is, it's already open, so let's close it, right? But the first thing we want to change is text. So if we go in here, we have different options for this. We have labels, we have notes for ANSI and notes for ISO. So we'll go into ANSI because we're on an ANSI one. And then you can see we can change what the font is and what the size is and a whole bunch of other things. Right. And so in our case, we will want to change this. We want to change this to 8 tends to be a good size. And then we say save and close. Don't just do cancel because it won't do anything, just save and close. And now you see that at least our numbers here are showing up as the right size. Right. And as we go along and do more and more things in here, we'll have to change more and more little details. Now, there is a way to change the template to have this automatically in there, but it is a huge pain to do. So what I would recommend you do is you create yourself one of these empty drawings where you change all the details around and you save that as, call it whatever, empty ISO millimeter drawing. And then whenever you create a drawing, you just open that, save it on a different name and go from there. So you keep that empty drawing and always start from that empty drawing. Otherwise, you have to go and change all these things every time, which is good because you then learn it, but on the other hand, also just is annoying. All right, but let's go back to actually putting our stuff in. So we'll go to the Place Views tab, and we're gonna choose the base. So we want to say what is our drawing basically, and so we'll have to go in and we'll find it. It will try and find basically the last thing that you worked on. It will default to that. So in our case, it's exactly good. We can change the style around a little bit if we want to. We of course we want to have hidden lines. We don't want to have it shaded. So we can make sure that's turned off. It's a little hard to see which one is on, which one's off. It's a little annoying. We can give it a different name if we want to, but that's not so important. The important one is the scale, right? So this is a little small for this piece of paper, so we can maybe try a 2. Maybe 2 is a little too small as well. Maybe 4 is maybe a little big, so maybe let's settle on 3. Right? And then it adds the 1 to 3, 3 to 1. I don't have to worry about that. So then we say okay, and there we have our front view. Right? If that's our front. And you can see that it's already putting all the stuff in, right? It's putting all the lines in that we want to. We said we want to have hidden lines, so it's automatically adding the hidden lines. And it's doing all this fancy stuff for us, right? This is the intersection of these two holes, right? You have the hole that goes straight down and the hole that comes from the side. Because they're intersecting, that intersection is no longer a nice straight line, it becomes an oval, right? But Inventor does all that for us. We don't have to worry about it. Now, what is missing from, if I'm just looking at my front view, what's missing from my front view? What did I potentially, I'm sorry? Dimensions, yes, but we'll get to that in a minute. The center lines, right? Our center lines are missing. The good thing is that Inventor allows us to do center lines. So we go to annotate up on the bar there, and then we'll look at these couples first here, right? So if I have a circle, I can use just the center mark. If I have a circle that's like that I see as the rectangular view, I can get my center line. So all I have to do is hit that center line one, and then find where my 2 sides of my circle are. So it'll be this one, and it draws in the center line. Now this one here we can do as well, this one, and it draws the center line. Now, center line ends right here, which is fine because that circle ends, like, that hole ends there, so it doesn't have to go any farther. We can do this one and this one. Now this one is not correct, right? Because the center line should go all the way down because that's where our hole is. So we go out of our center line command, and then we could just grab this and pull it downward. Try to make it look somewhat nice. This one should not intersect there, but that's fine. Right, so we can add those things there. Now we don't have to do a center line for these 2 because it's going to be the same. These are not a hole. Oops, almost wrong, right? That's our cut there, so it's not a hole anyway. So we have our center line, so I think this one is good now. Now the cool thing is that we don't have to go and do this step again and again for our 2 other views. We can just say, this is our front view, now create my top and my right side view. So if I go back to Place Views, then there's the projected command. And I say, well, it only has one, so it says, okay, if I have my mouse up here, it's gonna project it up there, and we'll put it somewhere nice, and you do a left click, so it kind of keeps it there. If I go over here, it does my front view. Again, do a left click. If I want to have my pictorial somewhere, I can stick that in there too. Like that. Now, once I've placed all the ones that I want to place, I have to right click and say create. I don't know how many times I have just left clicked and have to do everything over again. Right? It's a little annoying. And create. And there you see it creates all this for us. Now, what it does not do is it also does not add any of the circle, the center lines and the center mark. So we'll have to do that again. So again, we go to annotate. And now let's start with our center mark, right? So we have a center mark here, center mark there. It doesn't do the full center mark because that part is cut, but that's okay. We can live with that. We have a center mark here, and we have a center mark there.
Inventor, so the front view and the side view? Does it know what the?
Because that's an excellent question. It's because that's where I put my mouse. Right? If I wanted to, if we go back to place views, and I should have said that, right? If I go choose my party again, if I do it over here, it will do the left side view. If I do it down here, it will do the bottom view. If I put it up here, it's going to be do a pictorial from the different direction. Yeah.
My question was another one.
Okay.
Does Inventor know that the front view, side view, whatever view, it's like that just because of the front view we did?
Yes.
Or because it has the knowledge of our 3D
Your
object?
your 3D object means nothing to it.
Then what happens if the front view does not give it enough information?
Excellent question. So what we can do, if this were, if we place our part in here and it's not giving us the view that we want to see. So we could go back into our main view and we can do edit view. And you see that our little cube pops up again. Right? So if this had not been our front view, right? If let's say this would have been our front view, right? Then we can change it that way. Is that what you're asking? Or no? Right, so basically, if you've never tried this, it should be, yeah, it goes through all of them.
Like the orthographic view kind of forward by hand.
Yeah.
There were times where like the image in the front wouldn't give us enough information.
Right.
So how is Inventor deducing other?
It is not deducing anything. In this case, Inventor is very, very simple. What it does, it goes to your drawing and says, like, in your drawing, this is what you said is the front view, right? However you drew it, like, you know, if you said, I'm gonna take my initial coordinate system and I'm gonna place it on here, then that is the front view, right? If you had drawn it on there, that would still be the front view, right? That's what you decide. That's usually because you want to draw it in a way that's convenient to you, right? But if you, again, if you're placing your part initially, right? And if you say, let's say we had decided that the top view here is actually the more interesting one, right? So let's just create another one real quick. We'll not change anything just to show you how to do it, right? So you could say, I put my base in here, still doing the same part. Let's do 1, 2, 3 again, right? But now I say, well, this is not my front view. I think for my drawing, I want to have this to be my front view. Right? And then I can say, okay, and then I can do the same thing with my projected ones. It's now going to base it on this, right? This is going to be based on this. This would be the top view, and this would be the side view. And this would be my projected view. If I decide that this is my front view. Right. Right. If if I decide this is what my front view is going to be, then this is going to be my top view, right? So because now I'm looking at my piece in this direction, right? So my front view is now going to be what kind of was my side view before.
Can you go back to the previous example? Yeah. So what I'm saying is, for example, with the front view you have there, I know that, like, take for example, only like the left square.
Okay.
You know, there's a circle there. So Inventor and I know that given the front view, there's a circle. But then when it does the upper view, it assumes that the circle is in the middle. What happens if the circle is not in the middle?
Because that's where you put it. All right, it doesn't have to assume it's there. You put that circle right there.
So that one,
okay.
Inventor does know that my 3D object.
Oh yeah. Oh no. That's not what I meant. Oh no. I thought you were saying, does it know what the front view has to be?
Oh,
it doesn't, that does know, but it knows exactly what your part is. And actually, while we're on this, the really nice thing is that this part and that drawing are now connected. If I change my part, my drawing changes, right? So if we go in here and say like, well, actually this hole was not supposed to be where it is, right? We said it's supposed to be in the, that's the wrong sketch. Where is my edit my sketch, right? So if I say, well, it was supposed to be a different distance here. Right, we said that was 25, but if I want to have that 20, and I say finish, right, we can see that changes there without saving anything. It updates it there, right? Which is very cool, unless you're using one part for multiple things, and then you change it once, and then all of a sudden your whole set of drawings change. That's something that you'll see once we do like assemblies and you work on your project. So that can be a little tricky. But did that answer your questions sufficiently?
Yes,
Okay, good. All right, so now what else do we need? We need to have, let's go back to annotate. Let's do our center lines here. We don't need center lines there or there. And then here we need a gazillion center lines, and they're all going to look very nasty. We'll just have to live with it. There and there. I think we're good with that. All right. Now you said the other thing that we're missing, of course, are our dimensions. Right? We have to have dimension. That's a big part. And we can see in the same annotate one, we can choose dimensions. Now the cool thing is that because Inventor knows this part, we don't have to tell it how big something actually is. It knows how big something is, right? So if I just want to go in and say, I want to know this distance right here, for instance, right? I can put my thing in and Inventor does it. Every time I do that, it will open up this window. This kind of weird, like, bracket kind of things here, that is what it generates automatically, right? So if in this case, my height was 15, it will put 15 in there. If I don't want to have that in there, sometimes I don't, I can click this little box here. I can also put all kinds of other stuff in there if I want to, right? So if I want to say, this is a hole and I want to have it through, or I want to have it to a depth of 5 or something, right? You can see that I have all my symbols in here that I can use. Or I could just type things along as I want to, right? Obviously, that's not going to be very helpful, but we could. But let's let it just do what it does. And you can see it adds our number here. Now, do we like that number? Who remembers all the gazillion little rules that we looked at when we did dimensioning? What was one of the main ones? Horizontal. Same difference, right? And so we can actually now go in the same way that we change the text size, we can change all kinds of stuff about these dimensions. We can again go to manage and then in there, or we can say, we can right click. Nope, we have to do okay first. We have to be done with it to go out of our dimensioning command. Then we should be able to right click on it and you can see that we can go in and it will tell us which kind of thing it is that we want to change. In this case, we can say edit dimension style. And again, it takes a while for some reason to open up this little side menu. And let's get this out of the way. And it directly tells you, well, we're in default millimeter ANSI, so we can now change all kinds of stuff. First thing that I like to change is we'll get rid of our trailing zeros. We don't usually have those. Then the other important thing that we want to change is in here. As you will, can we see? Yeah, as we can see, those arrows are super tiny, right? We can't see the arrows. So here's another one, right? Remember, what did we, for the text, what number did we go to? 8, right? We went from 3 to 8. For the size of our arrows, we multiply by 4, right? So we say that's a 10 and that's a 4. The other thing that I like to do is I like to double up on this one to get, this is the space between my object and my dimension lines. Right? I just like to add that a little bit. And then the thing that we came in to change is right here. We want to have that horizontal. All right, and then we say save and close. And now it should look a lot nicer. All right? the text I did before, right? That once you change the label size, it will change it. The labels are basically everything that you put on there. And now I hope that you understand why I suggest that you do this once and save it. Because otherwise you have to do that every time you start a drawing. That's a little annoying. All right, so we can then go ahead and just dimension the whole thing, right? Let's get rid of this one because it's not really that in the right spot or anything. Remember that we like to do the baseline ones, right? Where we kind of start from one baseline and then stagger stuff out. Inventor will do that for us, right? So we can say, well, I want to start right here. I click on this one. I want to know where this one is. These are not sides of circles, right? These are our notches, so we can have those in there too. Want that here, want that here. Maybe I want the end one there. Now you see nothing's happening, but we do once we right click, we say continue, and then you can see it brings everything out. We click again, and everything is in place, right? Everything is nice in dimension there. Right? It makes sure that stuff is nicely spaced and all those kind of things. What it doesn't do is make sure that you're not double dimensioning or something like that, right? So you have to, that's something you have to do on your own. And then we can just kind of continue on dimensioning stuff here, right? So we can go into here. We can maybe dimension where all these holes are. No, I think we kind of overdid it, I think, with the size of our, no, we don't want to do that one. Because that one we need to dimension somewhere else. Again, we right click, say oh, continue, and then put that in here. All right. Right, so we can continue doing all kinds of dimensioning stuff. Oh, of course we have to dimension our circles. Remember that we want to dimension our circles in the circular view. Just click on the side, it creates our little drawings there. It already has the diameter symbol in there, so I don't have to worry about that. This one here. Now this one is going to be annoying, right? Because remember that we kind of cut that little piece of the circle out. So Inventor considers this now to be an arc, not a circle. So it will put the R in there. Not what we want, right? So this is one of the cases where we can say like, well, I don't want to see what it gives me automatically. I want to write my own. I want to do my diameter, and I want to do 30. Now we only want to do that if we can't do it any other way. Because if we now change that circle size, it will not change the dimensions, right? Anything else I change, it will automatically change, right? If I go back into my drawing, into my part, and say like, oh, the circle now is 40 instead of 30, right? It would automatically change that in my drawing, the dimension would change. But if I say, ignore what the actual thing is and do this, then obviously it's going to stick with that. So maybe what we can do, let's see. We grab this part down here. Does that assume this is the circle? No, it still thinks it's a, I thought it might grab the bottom circle of it and do it. All right, doing some yoga on the back there. Doing some yoga on the back. Why? Why? What did you over-exercise or? All right, let's get rid of this one because we need some space. Let's get rid of this one. So there's two more things I want to show you here. The first one is the reason why I put in this sloped surface, right? Because if we want the dimension on here, if we put a dimension here, from there to there, right, it will say, well, that's the horizontal distance, right? But we didn't dimension the horizontal distance, we dimensioned it on the slope. So what we can do is we can create ourselves another view. So let's go back to the views, and you see these auxiliary views. So I click on that, I have to click on my space right here, and then I get this new. It says give me an identifier and a scale. So we'll leave the same scale, and it will now, I need to choose which slope surface I want to use. So I'll choose this one right here. And doesn't really fit, but that's okay. We shouldn't have used 3, we should probably have used 2. But what it basically does, it now creates a view where this surface right here is flat. Right, in all my other views, it's at an angle. But now it's flat, so now if I want to do my dimensioning, again, let's put our center here under my center circle, right there. And now if I want to dimension where that is, did it from the top, it does the wrong thing. Interesting. Why is it not grabbing the right distance? Did we not do 24? Let's see, that would be this one right here. We said 25. Oh, that's the wrong one. Why is it not doing 25? So from that to there. Oh, there we go. I grabbed something wrong. Right, so now it dimensions it in the right location. Now, in this case, we don't have to worry about it being horizontal or vertical. That's kind of off, right? That's not something we'll do very often. I just want to make sure that you know it exists. And then the last thing that I want to show you is if we go back to place views, we can get a detail. Right? Sometimes you have a very big drawing and there's something very small in the corner somewhere that has a lot of detail that you need to kind of blow up. So if we want to kind of look at more detail in this area here, we can say detail. Okay, you need to click to whatever you want to go. It now says it's B because it needs to give it a name. And then you kind of click into the center where you want to have it, hold your mouse, draw it out, and say, okay, error in view creation. Yeah, that's this. Oop, that's not this is what I want. All looks good. There we go. Now, again, we don't have space. We should have done it smaller. We'll just have it sticking over here. Right, so what you can see, it makes it bigger. And it kind of does this scraggly line around it to show that this is not part edges, right? And so now I could go into here, go back to annotate, and I could, do my distance here, for instance. Or I could dimension stuff in there. All right. Questions about any of this? Oh, that's why you're gonna do a whole bunch of exercises to remind yourself. That's why we do all those steps, right? So but before we go there, two things. The first one, remember that whatever you change in your drawing now gets translated into here, on your part, right? If I go back to my part and say, well, I didn't want this hole to be size 20, I want it to be 25. Right, makes that hole bigger. If I go back to my drawing, it did not want to do that for some reason. Oh, because it bumped stuff out of it. Okay, we need to make it not quite so big. Let's do it 15. Let's go in the other direction. Right, so it made it smaller, and it changed the label as well. Right, so it does all this by itself. Now, the other thing that I just wanted to very quickly show you, because Alberto asked me about it, and I think I finally figured out what it was exactly that he was asking me about, and I know how to do it. And that is, if you're drawing on the inside of things, right? Sometimes if you want to draw on this surface, for instance, right? Let's say we want to do a sketch here. It's blocked, right? I can't see what I'm doing. I could kind of do this and then draw onto here, but that's kind of annoying, right? So what you can do is you can basically, if we go back to our view here, if you hit F7, not if you're on this mode, then it basically does a cut through your system to your entire part, right? It creates a section, pretends as if it's cut right there. So now you can draw on the surface and you can still see what's going on, right? So I can say, well, maybe I'll draw a little rectangle here. And I do a finish, right? Then it leaves the part where it is. Yes, yeah. Now, in some, there are also ways to kind of get rid of parts of your big of your object, but then you'd have to create multiple solid bodies, right? Right now we only have one solid body. You can hide that one to make it invisible, but then you can't see anything anymore. So it's not really all that. No, if you just finish the sketch, right? This is only happens within the sketch. As soon as you leave the sketch, it goes back to its full thing. All right. So, guess we can